Hi everyone. In this video we're going to go over solving radical equations. So just as a reminder, in the last video I talked about solving absolute value equations, and today is going to be the second video for solving just different types of equations in pre-calculus. So just as a reminder, when you're solving radical equations, you're going to have problems that either have a square root symbol or a cubed root symbol, or you could even have something like a fifth root symbol. And so you're going to want to know how to solve each of these different types of problems. Okay, so we're going to take a look over here at these two first example problems, and then you're going to do some on your own. So we're going to start off with a basic one. If I've got the square root of x equals 4. So to solve this problem, I need to get rid of my square root sign. Since this is a square root with a power of 2, in order to undo my square root, I'm simply going to square both sides of my equation. When I do that, my square root is going to cancel out on the left along with my squared, so that I'm just left with whatever's inside of my square root. So I just have an x. And then 4 squared, that's going to give me 16. For this type of a problem, because my x is not over here on this side, I don't have to do a plus or minus because x can't actually, in this equation, x can't actually equal a negative number. So there's no plus or minuses with these types of equations. Okay, so that was the pretty basic example. Let's look at a slightly harder one. So I've got 5 plus the square root of 3x minus 11 equals x. In order to solve these problems similar to the absolute value equations, I want to get the square root on one side. And everything else that's not underneath a square root onto the other side. So in order to do that, I've got this 5 over here. I'm going to need to subtract 5 from both sides so that my square root is by itself. So now I've got the problem, the square root of 3x minus 11 equals x minus 5. So now I can do exactly what I did up here. I want to get rid of my square root. So in order to do that, I'm going to square both sides. When I do that, on my left-hand side, easy stuff, my square root just cancels out. I'm just left with 3x minus 11. But over here, I've got to be careful. I don't just distribute in my power of 2 to my binomial x minus 5. Instead, I've got to kind of expand this out. So this actually means to multiply x minus 5 times x minus 5. It's helpful to write that out so that you remember to FOIL, and you don't just do x squared minus 25, because that's not the same thing. So now I've got to distribute out and multiply through. So this becomes 3x minus 11 equals x squared minus 5x minus 5x plus 25. Now I'm going to keep simplifying, so I've got 3x minus 11 equals x squared minus 10x plus 25. And now, kind of similar to the absolute value equations, I've got this quadratic, and so I want to figure out what x squared, or what x can equal. So in order to solve any quadratic equation, I've got to get one side of my equation equal to 0. So I'm going to add 11 to both sides, and I'm going to subtract 3x from both sides. So this becomes 0 equals x squared minus 13x plus 25 plus 11, that's going to give me 36. Now I'm going to see, okay, can I factor that out, or do I need to use the quadratic formula? So I'm looking either for two numbers that multiply to 36 that will add to 13. And I think I've got a set. So I'm going to do snowflake over here on the left. My a value is 1. I'm multiplying to 36 and I'm adding to a negative 13. I think that negative 9 and a negative 4 will do the trick for me. So my two binomials are going to be x minus 9 times x minus 4, and that's equal to 0. To find my actual solutions, I'm going to set each of these pieces equal to 0, so x will equal 9 and x will equal 4. So last step, similar to absolute value equations, I also need to, at this point, check for any extraneous roots. And so I'm going to do that the same exact way that I did for my absolute value equations. Once I've isolated my square root, so I'm going to go back up to this equation. I'm going to graph these two pieces before I've squared it. So I'm going to go back to the equation. I'll go over here. The square root of 3x minus 11 equals x minus 5. And so I'm going to graph these two separate equations. So I'm going to set my y1 equal to the square root of 3x minus 11, and my y2 equal to x minus 5. So at this point, you either want delta math out or Desmos, whichever you prefer for this. In class, you'll be using the graphing calculator. And I'm going to see where these two lines intersect. So in my calculator, I'm going to type in the square root of 3x minus 11, and then x minus 5. And I'm going to hit graph. And I notice that they intersect over here. I'm not really sure what's going on over here. So I'm going to make my x values larger and cut off these smaller ones because I really want to see what's going on over in this part of my graph where I can't really see. So I'm going to change my window. So I don't really care about my negative x values. I'll start at 0. And maybe this time, 0. And maybe this time for my x max I'll go to 15. Okay, so now we can tell that these lines definitely only intersect at one point. This line keeps going up and up and up and up, versus this line is going up very gradually. So they're going to keep moving far apart from one another. They're not going to intersect again. So I just need to find that one intersection point. So I'm going to go second calc over to intersect, get kind of close to that intersection, hit enter, enter, and enter one more time. And I get that x equals 9 is where they intersect. So I can see that right down here. X equals 9. So what that means, I had these two solutions, right? I had x equals 9 and x equals 4. What that means is that x equals 9 is a solution. X equals 4 is extraneous. So it is not a solution. Okay, on your own now, you're going to give a couple of these a try. So here are 4 problems for you. Go ahead and pause. You want to identify any extraneous solutions. Going through a couple of these, you just want to make sure that you checked for extraneous solutions before you move on, but you probably saw what the correct answers are. And so we're going to go through a couple of them algebraically and then double check graphically what our solution should be. So for this first one, I've got 6 plus the square root of x equals 5. And so when I subtract 6, I get the square root of x equals negative 1. Well, that should send up a red flag because my square root can never be a negative 1. So even if you went through and you solved, so you squared both sides, and you got x equals 1, you should have seen that when you graph that set of equations, and I'll go into Desmos here, when you graph that set of equations, you've got your x squared here, or square root of x, and x equals negative 1 down here, and they're never going to touch. No matter how far you zoom out, these two equations are never going to line up or intersect. So there's actually no solution to that equation. Oops, sorry. Okay, let's look at the next one. So we've got 4 plus the square root of x plus 1 equals x. So for this one, it was a slightly longer one. You should have subtracted 4 from both sides and then squared both sides. So that over here you've just got x plus 1. And over here you've got to factor out or FOIL out your binomial. So you get x squared minus 8x plus 16. Now in order to solve a quadratic, I've got to get the whole equation equal to 0. So I'm going to subtract 1 and subtract x from both sides. And this equation unfortunately does not factor out nicely. So I've got to use the quadratic formula. And when I do that, I'll be left with 9 plus the square root of 141 over 2 and 9 minus the square root of 141 over 2. And so now I've got to kind of figure out, well, which of those answers makes the most sense. So when I graph this, I can see my two lines. So here's my square root of x minus 1, or x plus 1, sorry, and my line x minus 4. And so when I graph these two, I can see that there's an intersection at 6.79. So that's where x is some positive number. So I'm not really sure, going back to my solutions, I'm not really sure what these two numbers are. So in order to check my work, I'm going to type this into my graphing calculator to see if I can figure out which of those solutions is actually my solution. So 9 plus the square root of 141. I'm going to take that whole thing and divide it by 2. And I get 10.437. Well, that didn't match up with this solution over here, so that can't be right. So let's try my minus route. 9 minus the square root of 141. That gives me this whole thing, and if I divide it by 2, I get a negative 1.43. That didn't make sense, and you probably caught my... So when I subtracted 16 minus 1, that should have given me a positive 15, which means that that's a positive 15 in here, not a negative. So if I take 81 minus 4 times 15, that means inside of my square root, I've actually got 21, not 141. So that was why that mistake was there, or why you may have noticed that. So now when I figure out what these two solutions are, so 9 plus the square root of 21, and if I divide that by 2, okay, now I get my nice 6.79 that I was looking for before, where these two lines intersect. So that should be my one solution, which means that my 9 minus the square root of 21 over 2 is extraneous. 9 minus square root of 21 over 2 is extraneous. So taking a look at these next two, I'm just going to do these graphically. So these two, I'm only going to do graphically. If you didn't understand where these two solutions came from, please make sure that tomorrow in class we talk about it so that you can figure out how to solve these on your own. 3. When I look at where these two lines intersect, again, it's only 1 point, which means that I've got an extraneous solution to these two lines. So my graphs intersect when x is 4.75. So I'm going to look back at my answers. You should have gotten, when you did the quadratic formula, 27 plus 11 over 8 and 27 minus 11 over 8. 27 plus 11 over 8, that's going to be 38 over 8, which when you type that into your calculator will give you 4.75. So that's actually going to be your solution, which means that this second solution, so when you get 16 over 8 or 2, this is going to be extraneous. Okay, let's go ahead and look at this last one graphically. Let's look for some solutions. If those two equations, the square root, I'll pull it back up, the square root of x squared plus 3 and 4x minus 1, my two lines should look like this, and I've got an intersection point when x is equal to 0.72. So again, in order to solve this problem completely, I've got to go back to my two solutions, which when you solve them algebraically, you should get 8 plus the square root of 184 over 30, and 8 minus the square root of 184 over 30. So I've got to plug those two into my calculator and see which gives me 0.72. So if I take, let's see, 8 plus the square root of 184, and I divide that by 30, I get 0.7188. So that was my solution, which means that this has to be extraneous. And so make sure that you identify which problems you did not understand in the video so that tomorrow in class you can ask questions.